Good afternoon, my followers. Please, today I want to solve problem on triangular glass prism. That is light waves. You are given a 60-degree prism. It's made up of a material whose refractive index is this 1.6. Calculate the angle of minimum deviation. So how do we solve that? What are the parameters given? Angle of prism is given as what? 60 degree, and the refractive index is given as what? 1.6. Okay, so the formula refractive index is given as sine of minimum deviation plus angle of prism over 2 all over sine of angle of prism over 2. So this refractive index is 1.6 equal to sine of minimum deviation plus angle of prism 60 over 2 all over sine of 60 over 2, that is sine A over 2, which is 6. Okay, so I'm going to have, let me cross multiply, that will give me sine of sine minimum deviation plus 60 over 2 will give me 1.6 times, this is 60 divided by 2 is 30, so you have sine 30. Okay, now I'm going to make the whole of this inside the bracket the subject of the formula. I'll take the sine inverse of this. So minimum deviation plus 60 over 2 will give me sine inverse of 1.6 times sine 30. Okay, as you can see, sine 30, let us check. Sine 30 is giving us 0.5. So I have 0.5 minimum deviation plus 60 over 2 will give me sine inverse of, this is 0.5 times 1.6 times 1.6. If I multiply it by 1.6, I'm going to have 0.8. So I have here as 0.8. Okay, so what I'm going to do now is I have minimum deviation, which is this, plus 60 over 2 will give me sine inverse of, I have the sine inverse of 0.8. That is sine inverse of 0.8, and it's giving me 53.13. So I have 53.13. Okay, now what I will do is minimum deviation will now become this times this, that is 2 times 53.13 all, okay, this times this. Okay, now minus 60, and that will give me, so I'm going to have 2 times 53.13. okay, that gives me this minus 60, so I have my answer as 46.26. I have 46.26 degree. So that is the answer. I take this one, we multiply by this, then this crosses over to become minus. So this times this minus this will give me this answer. So this is the minimum deviation for this problem. Thank you.